Hello, welcome back to episode 4 in the network security topic of CSC 280, Introduction to Cybersecurity at Adelphi University. This is the last video in the network security topic before we move on to the next one. In this video, we'll look at enterprise security technologies. We've looked at networking. We know what host names are, domain names I should say, IP addresses. We know what a router does and how routing on the internet works from a very high level. And we looked at some diagnostic utilities like ping, traceroute, and NSLookup. So next we can start looking at specific defensive security technologies. And of course those are all depending on what kind of attacks are we facing. Now, this introduction is a fairly high-level introduction. We'll go in a lot more detail in CSC 380, Computer Network Security, where we also do some hands-on work with them. In this particular video, we're just going to talk about what these technologies are and roughly what they're being used for. As before, I'm going to take some shortcuts here and there just for the clarity of instruction. By far, the most well-known security device is the firewall. First thing people will ask for, especially people who are not security trained, is, do you have a firewall? And is it a good one? Was it very expensive when you bought it? Maybe. Without really having an understanding of what the firewall does. And it's important to realize that a firewall has a very specific function. And that it may be okay at performing that function, but it is definitely not the end-all be-all in cybersecurity. The firewall provides a central point of visibility and a central point of control, and in particular of network separation, so visibility and control into network traffic at the point where that network traffic flows from a trusted network to a less trusted network. It's an access control device. We talked about access control models in the past, and then we talked about these things called isolation. And we talked about full mediation. The networking equivalent of that is the firewall. The firewall must separate all traffic, not just some of it, going from one network to the other. Because that means that you only have to look in one location, and you can enforce your access control policies in one location. And that's what the firewall does. So again, it's a device that provides a single point of visibility and a single point of control for network traffic that flows between networks of different trust levels. There is often little or no use of putting a firewall between two trusted networks. Yeah, there is some, but that's not where it's really the main purpose comes. Most firewalls are configured to deny all traffic that isn't particularly authorized, and in particular traffic that is coming from the untrusted network into the trusted network would be refused unless there was a specific permission to let it through. Again, least privilege. If you don't have to do it, don't do it. On the other hand, and that's mostly for a convenience factor, in the other direction, from trusted to untrusted network, many firewalls are still configured to default allow, to let all the traffic through unless it is specifically prohibited. And that comes back to trust, and we've talked about trust in the past. Ideally, you want to regulate traffic in both directions. In and outbound traffic should be limited and inspected, especially when it is potentially high value data that flows there. Now, firewalls, network firewalls, like the ones we're talking about, are configured by IP addresses, not by host names, but by IP addresses. And if you start digging deeper into networking, you'll start learning about things like TCP and UDP and ICMP. Those are called transport layer protocols. That's something a firewall can do as well. But a firewall, a traditional firewall, can't, for example, say, okay, let HTTP traffic go through to this web server, because that HTTP traffic happens at a higher level of abstraction. We'll worry about that, the TCP IP stack and the OSI stack, in classes like our networking class and our computer and network security class. But for now, let's go with a firewall only works on IP addresses and maybe protocols and port numbers like we saw there. The configuration of that firewall is known as the access control list. It basically specifies who can go through and who cannot go through, which is sometimes shortened as an ACL or an ACL. Now, reality, of course, I've mentioned this several times in this topic, the reality of networking is much more complex than what I make you believe here, but the big concepts stand. The firewall is configured by explicitly specifying what traffic is allowed through and which is not. And then it will enforce it. It's just an access control device. So for example, I've drawn a small picture here of a network. Actually, we have three networks. We have the unknown and therefore the untrusted internet, for example, the network top left. And then I have two of my own networks. I have a network where I put my servers, and I have a network where I put my office equipment, my PCs, my printers, my scanners, all that kind of good stuff. And I put both of them behind different firewalls because I want to limit what goes in and I want to limit what goes out. Conceptually, you can think of them as different firewalls, although in the end you might buy a device that can have multiple of these firewall zones or interfaces associated with it. So let's say that my server network has a server in it with IP address 172.16.12.4. And my office network is the whole range of 10.12.16.0/24. We know what that means. We talked about that in one of the previous videos. Now, on a server network, I really want to control everything going in and everything going out. So when I start looking at that access control list you see on the slide behind me, you'll see that the first rule says, okay, allow from the internet to the web service on that IP address. I'm taking some shortcuts, I'm abstracting away from some of the technology, but it's a specific allow. Now, the way that these access control lists typically work, once I hit the first rule, I'm going to stop processing. So, as long as I'm coming from the internet and I'm going through the web service running on that server, none of the other rules apply. But if I'm not going to the web service on that computer or I'm going to a different computer, processing is going to continue with the second line. And it's going to say deny from the internet. No conditions. So it means that really I'm only allowing from the internet web services traffic to that particular IP address. Everything else is stopped. I'm also saying I'm going to deny everything from that server to anything on the internet. So what I'm basically saying, if you're on the internet, you can only get to this server via the web service, and the server itself can't go back out to the internet even if it wanted to. The firewall will stop it from doing that. That's a good practice. And then lastly, just to make sure that we didn't miss anything, although in this case it's difficult to understand that we would have missed something, you create the default policy, which basically says deny everything from anywhere to anywhere on anything. So that's called your default deny at the end. So this is a very much restricted server network on the top right. On the bottom left is my office network, and I'm going to configure that differently. I'm going to say, okay, if I am coming from my internal network, 10.12.16.0/24, and I'm going out to the internet, or I'm going to my server network, because it says all destinations on anywhere, it's good to go, you're allowed through. But I'm also saying if I'm not coming from inside my own network, I'm coming out from the internet, I can't come in at all. And that's the typical behavior that you see. Even when you have your Wi-Fi router at home, which has a small built-in firewall as well, unless you specifically allow port forwarding or port triggering, nothing is going to get through. And again, that last default deny thing. So the firewall does that. The firewall makes sure that traffic that is not allowed stays out, traffic that is allowed to go through goes through, but it's very tricky to configure them well. So by themselves, firewalls do some good, but they are difficult to operate and they are limited in their effectiveness, and I'll tell you why. Now, I said firewalls only filter traffic at the network level or at the transport level, at TCP and that UDP level. But maybe I also want to go a little deeper. I might say, okay, it's fine that you want to go to the web service, TCP port 80 or TCP port 443, but I want to actually look at the data that you're sending there. Is that actual web server traffic? And maybe I want to be able to say, if it's not web server traffic, you can't go through to that port. If it is web server traffic, you can go through to that port. The firewall cannot do that. The firewall can only say if you're going to the service that is meant for web, then you're allowed through. It can't see what you're actually doing there. And so, if I want to have that level of inspection, I have to look inside the network traffic. And that is the role of the intrusion detection or the intrusion prevention system. For the scope of this course, you can think of them as the same thing. The only difference is an IDS will alert on things it sees out of the ordinary. An IPS, an intrusion prevention system, will actually go out and actively stop that traffic and make sure it doesn't go through. The reality is more detailed than that. Next class we'll look at that in 380. So the IDS is nothing else but alerting. The IDS that also blocks is no longer an IDS, it becomes an IPS, an intrusion prevention system. Important to realize is that both firewalls and intrusion detection or intrusion prevention system are considered to be perimeter-based defenses. They sit on the edge of the network. They keep traffic away from the network or they keep traffic inside the network. It's like a gate around a property. Now, some gates are meant to keep people out, other gates are meant to keep people in. But once you're inside the property, inside the network, the firewall doesn't do anything for you anymore. So perimeter-based defenses only work on the perimeter, which means that once you're inside the network, most likely the firewall and the intrusion detection system don't do much good anymore. Okay, we'll look more at IDS and IPS technology in future classes. Important to realize is that IDS and IPS technology is becoming increasingly ineffective because of the use of network encryption. Remember, an IDS or an IPS is based on the premise that I want to look inside the network traffic to see what's going on there. But as I start putting on network encryption using TLS, transport layer security, all that stuff that's going on in the network is completely encrypted. And even though it's encrypted, I can look at it, I can't figure out what it means. And that means I can't draw any conclusions as to whether this is good or bad, whether I should block or alert on it, or if I should have just let go. And so, while the IDS or the IPS might be able to intercept network traffic because of that increased adoption of encryption, it just becomes a lot less effective overall. At the moment, at Adelphi in our practice, we see that close to 90%, if not more than that by now, of all the network traffic traversing our firewalls is encrypted network traffic. So at that point, it doesn't really help all that much to look at the content because you don't have any access to it. Now, you could play tricks with that by doing inline decryption, but that requires a level of infrastructure that is often not feasible on a predominantly bring your own device network like ours. And secondly, I don't want to be looking inside your network traffic. I don't want to see what you're doing on the internet on an evening in the dorm rooms. Thank you very much. Right? And so we don't inspect the content of traffic. One, because we really can't, and two, because we really don't want to know what's in there. But that also means that IDS and IPS technology is becoming increasingly less effective. Now, I do have something called an application-aware firewall, which is a firewall that I can configure to not look at, say, IP addresses or port numbers, these transport layer constructs, but literally at the type of network traffic. Like, if you want to come from the internet and you want to be talking to a web server using the HTTP protocol, you're allowed to. Otherwise, you're not. And at that point, I really don't care, for example, what port you're doing this on. Those are called application-aware firewalls, sometimes known as next-generation firewalls. But the reality is a next-generation firewall is often just a firewall, traditional firewall, and an intrusion prevention system rolled into one device. And if you think about them as two separate functions, the fact that they happen to be sitting on the same device is really not all that important. Yeah, sometimes it's more cost effective than having multiple devices. The latency that you're inducing by adding more network equipment could go down. So there's all kind of good reasons why a next generation firewall is a good place to look. But essentially, if you look at the core function of the thing, it's a convenience factor. It's not something radically new. The next generation doesn't bring really much new. It just brings efficiency and convenience. But they do exist. Application-aware firewalls and next-generation firewalls, which are often considered to be the same thing. But again, their role is the same. They separate trusted from untrusted networks, and they do that not just by looking at network layer traffic, but they look inside the traffic to make sure it's in compliance with the policies that are configured in there, and those policies still look like access control lists. So between firewalls and intrusion detection and intrusion prevention systems, those are not the only two network security technologies, but they are responsible for a good 50 to 60% of what you see out there, if not more than that. Another category is the VPN, the virtual private network. We might know VPNs as a way to stream videos that are limited by geography, country specific. You can stream this because you're not in the UK. You can't stream this because you're not in the Netherlands. Oh, I'll get a VPN that terminates in the Netherlands, and the network will think that I am in the Netherlands. That's useful, but that's not the primary enterprise reason why we would use VPNs. Let's say that I'm on the road. I'm a telecommuter. I'm at home working, and I need to access servers on the internet, on the internal network. Those servers I don't want out on the internet. They have maybe some really important data on them, and I don't want to run the risk that anyone on the internet can get to them directly. So in my firewall, I've said, if you're trying to access this server from the internet, you're not going to be allowed through. Well, I'm telecommuting, which means I'm coming to you via the internet. So I have to find a way to solve this, and that's where the VPN comes into place. The VPN is an extra service that you can connect to. So in other words, if I am at home, I will connect to the VPN service. And you can think of that as a tunnel that starts on my end at home, and at the other end of the tunnel sits behind the firewall. And that means that any network traffic that I push into that tunnel on my end at home comes out of the tunnel inside my organization on the other side of the firewall, and all of a sudden I can access those resources. So it's literally like poking a hole in the firewall that I can send data through. What makes a VPN more interesting is that it's encrypted. And we've looked at encryption in the past when we talked about integrity protection and confidentiality protection and authentication. All of that stuff the VPN does. So in other words, if I have a well-configured VPN and I connect to it from home, I know for a fact that I am talking to the VPN at my workplace because cryptography has verified that for me. Just like the VPN server on the other side knows it's me because I have had to provide some key pairs, for example, demonstrating my identity. It's encrypted, it's authenticated. So now I'm not only guessing that I'm probably talking to a VPN server on my enterprise network, I know for a fact that I am. Just like that the enterprise network knows for a fact who I am on the internet. And because I am authenticated as a user on the internet, and I'm sending communications into my enterprise network via that encrypted tunnel, I can have more access than I would otherwise have. And that's what the VPN is meant for in an enterprise environment. So that's why we use VPNs when we're telecommuting, because it puts us behind the firewall. We looked at a very high-level overview of network security and networking. The key takeaway lesson here is that networking is complex and that lots of networking is still based on trust. I have to trust that the router is doing the right thing. I have to trust that DNS is doing the right thing. I can check a few things using those diagnostic utilities like ping and traceroute, but I can't check a whole bunch of stuff, which means that I have to add extra technologies to my network, and that technologies could, for example, be firewalls, intrusion detection system, intrusion prevention system, VPN server, but all of those are things I have to add to my network because the network by itself is not trustworthy and insecure. And as long as you keep that last bit in mind as a defense person, the network is insecure, the network is not trustworthy, and I have to pretend like I can trust it by adding lots of controls to it, you have learned an important lesson. This is not a class on networking. This is not a class on network protocols or on application level protocols. The whole point here was to start to understand how the internet works, and especially it's a miracle how well it works given the fact that it's all trust-based and that we can do some things to make it better, but that still all the technologies that we add to the network are really patches for something that was not designed with security in mind in the first place. In CSC 380, which we're running next semester in the spring, we'll dig more into this and we take more the offensive perspective there than the defensive perspective we're taking here. How can I leverage that trust in order to gain access to the network? How can I break into a network by exploiting these vulnerabilities? How can I, etc. That's 380. Today we're just looking at bigger pictures and more defense. Next week we'll talk about vulnerabilities, vulnerability disclosure, and vulnerability management.